So this is the beam over here. So this is a simply supported beam. So one support is the hinge support and another support is the roller support. Okay, to make it a bit tough, we'll add another roller support over here, right? So in this span of the beam, we'll apply a load of 10 kilonewton at the center. So let us take this span as 5 meters. Okay, so this is 5 meters and this span over here is 4 meters. So we'll apply the load at center, and in this span we'll apply the load at 1 meter from this support. That is, this distance is 1 meter and this distance over here is 2.5 meters, right? So this is 10 kilonewton and here we'll apply the load of 5 kilonewton. Okay, so let's do it. So go to file and click on new model, and over here click on use built-in settings with. So display units, select metric SI, gives you the unit of length as meter and unit of force as kilonewton. So a US customary will give you the force in kilonewton and the length in feet and inches. So we'll go with metric SI for now. And still database we don't need right now, but you can select any of these options over here. So I'll choose Indian here. And still design code, this also we don't need, but you can choose any of the code that is followed in your country. So I'll choose IS 800 2007. And concrete design code, you can select any of the code that is followed in your country. I'll select IS 456 2000, that is Indian standard code. So I live in Nepal, and in Nepal we follow Indian standard codes. Okay, so we just click on OK. So after that we see this dialog box where you can edit the grids. Okay, so here we are drawing this beam, and this point over here is our origin. So let's change the color, let's do it the red, and we know that in this direction we got our y-axis, and in this direction we got our x-axis, and in the upward direction we got our g-axis, right? So what we now do is we define the first grid for this joint. So that is a grid that lies in this direction, and the next grid we'll have for this support, that is the B grid, and next grid we'll have for this support, that is for the C grid. Okay, alternatively you can also define the support for these loads as well. In that case it will be B, it will be C, it will be D, and it will be E. All right, so we don't need any grids in the Y and the G direction, but we'll need a single grid line for Y and G direction. Okay, so here we'll not be drawing these two grids. Okay, these two grids. So we need a grid at 5 meter from the origin for this support, and another grid should be at 5 plus 4, that is 9 meter from the origin. So we change our data accordingly. All right, so here it says uniform grid spacing. So we are not doing the uniform grid spacing because our grid spacing varies. That is why we'll go with the custom grid spacing. So here we'll click on edit grid data, and edit grid system data dialog box appears. So you can change the name of this grid over here. And another is a rectangular grid system. So there are two options by which you can define the grids. One is using the ordinates and another is using the spacing. In this video we'll see this option, and in the next video we'll see this option over here. So X grid data, that is the grid data in the X direction. So they are numbered as A, B, C, D, and you can see this thing over here as well. So X ordinate, so we need a grid at 0, that is at the origin for the hinge support. Another grid is at the 5 meters, so we'll click on 5 and hit enter. So you have to check the units over here. All right, and next grid we need at 9 meter from the origin, so next is 9 and hit enter. So we don't need this grid, so we'll just delete it. Okay, all right, so in the Y grid we don't need any of these grids, but we'll need a single grid line, and we just click on, after selecting these we just click on delete. So bubble size you can change, so size of these bubbles you can change if you want. Reference points and reference planes, so these options we'll see when we model the real building. So after that just click on OK. So here it says story dimensions, so that is these are the grids in the z direction. So number of stories, you can change these values for now, or you can just keep them as they are, because we are just drawing a simply supported beam and we don't need anything in the height in the stories. So number of stories, to make it simple, just click on 1, and after that just click on OK. So now you can see over here, this is the XY plane and this over here is the 3D view. Okay, so if you see the beam, then you can see that you can visualize the beam and the load in the XG plane, right, in this plane over here. So what we do, we just go to the XG view in this window and we'll keep the 3D view in this window. So over here there is an option to change the view. So here it says the plan or the elevation, so we are going to the elevation. So click on elevation over here, and here which view you want. So here you can see that this grid system is numbered as 1, 2, 3 and so on, right, and this is as A and B and C, right. So so the A option means, so if you click on A option and hit OK, so it will give you this elevation over here, and if you click on B and hit enter, it will give you this elevation over here. So what we want this elevation over here. So for that we have to click on 1, right. So same thing we do, click on 1 and click on OK. Now you can see you got the XG plane, right. So click on 3D window, just rotate this because it doesn't give a very good view. So zoom out. So for zooming out, use the middle mouse button, scroll down just like you do in the AutoCAD if you're using. After doing this, we draw a simply supported beam. Alright, so for drawing anything, you have to first define the material, define the section, and after that only you can draw. So but here we are just seeing how Etab basically works, right. So we don't have to do these things in advance, and we'll learn these things while we design or while we model our real building. Okay, so we'll just draw a simply supported beam without considering its section and its material. So we go to draw and click, and over here if you hover on draw beam column brace, another option appears. So over here, draw beam column brace, you can click on this option. So these icons over here you can see here as well. So it means that you can either click here to activate that option, or you can activate those options using these menus. Okay, so click on draw, hover over here and click on draw beam column brace. So here it says properties of the objects, and now you can see that if you click here, then an option appears. So this shows that you're drawing a beam. So we got a hinge support at this point, we got a roller support at this point, and we got roller support at this point. So what we do, we draw a beam from here to here. So we click here, so that is of 5 meters, you can see the length, and again after that we click on here, that is of 4 meters. Okay, so your clicks should be precise. Alternatively, what you can do is that you can define grid for your load, and you can draw your beam from this point up to the load and again up to the support. Okay, so there are 2 methods, you can use any of those methods, right. After that, just click on this close option and hit escape to escape that command. You can see that Etabs has automatically assigned hinge supports to these joints. So what we'll do, we'll change these supports. Okay, so click here and click here, and after that go to assign. So in Etabs, whatever you have to assign to your model, you have to go to assign menu. Okay, so we'll assign the joint and click on restraints. After that, over here is the roller option, click on roller and click on apply. You can see that now you got rollers and 1 hinge. Okay, just click on OK. So after assigning the joints, now we'll assign the load. We will first apply the load on this beam. So click on this beam. Okay, so left click and go to assign. So beam is a frame, right? So we'll apply the frame load. Okay, and over here we are applying the point load. Click on point. So load pattern name is dead, so that is already defined by default. Okay, I will know how to define these loads later. And load type and direction is forces, direction is gravity, and point load. So there are two options over here. So one is relative distance from end I, and another is absolute distance from end I. So this end of this beam, so this beam from here up to here, so this end is the end I. So relative distance from end I means that Etabs will consider the entire span of the beam as 1 meter, and based on that conversion it will apply the load. For example, our beam is of 5 meters and we're applying the load at center, that is at 2.5 meters. So if this 5 meter is taken as 1 meter, then the load will be applied at 0.5 meter, that is at the center. We'll use this option, so relative distance from NI. So distance is 0.5, that is at the center of 1 meter. So over here we'll apply the load of 10 kilonewton. Okay, and relative distance from NI, and click on apply. You can see that downward direction load of 10 kilonewton has been applied. And in the next beam we have got the load at 1 meter from this support. So what we'll do, we'll just use the absolute distance from NI option. We'll select this beam, and at a distance of 1 meter from NI, that is this end. So now this end has become the NI for this beam. We'll apply the load of 5 kilonewton. So we'll apply the load of 5 kilonewton, and options over here shows that add to existing loads. So add to existing loads means that if you have already applied a load, for example at this point we have already applied the load, and if you want to add any other load, you can use this option. So next option is for replace existing loads. For example, if you apply 10 kilonewton load, so suppose that by mistakenly you applied 20 kilonewton load earlier, now you want to replace it with the 10 kilonewton load. So in that condition you just give the load value here and click on replace existing load. 20 kilonewton load value will be replaced by the 10 kilonewton load value. Okay, and delete existing load means that it will delete the existing load that is applied on your structural member. Okay, so just click on okay, so give the value of 5 and click on apply. You can see that 5 kilonewton load has been applied at a distance 1 meter from this support. Click on OK.